This is Algebra 1, Term 2, Lesson 8. Today we'll look at systems of equations. The first activity will be a really fun Desmos activity, turtle time trials, and then we'll revisit stacking cups and ask some more questions. Then a graspable math activity, and finally a partner task using a GeoGebra puzzle activity. So let's start with turtle time trials. This is the Turtle Time Trials, a very popular activity in Desmos classroom. Doesn't give a suggested time here, but I would say at least 45 minutes, maybe up to an hour, depending on your students. This could be an 8th grade activity, so it might be something your kids do quickly. But on this one, they will play little videos and look at the race. Two turtles racing, and of course they're going to add turtles to the mix here as you go through the activity, and they're going to add tables that you're going to fill out. So adding a number line here at the bottom, they can use that to gauge the distances that the turtles are traveling. And then they're going to talk about speed. So here we'll do rate, which is distance divided by time. A lot of these are proportional relationships. That's not really specifically spelled out, but it will be things they've seen before. For example, this line, lane 2, is a proportional relationship, and lane 1 is not a proportional relationship, because you can see he started, and you could have a discussion. You know, if he start at the origin, 0, 0, then we call that proportional. When they start somewhere not at the origin, then it's not proportional. This line is going to be proportional, so the question is, where should you put this line so the rate in the video matches the rate showing up in this graph? So rate of change is the same as slope. Some good teacher moves and sample responses are in these are down here, so be sure to check on those as you go through this activity. You do want to pace your kids so that they're not just skipping ahead to look at later screens to get answers. Here they're doing equations, and they're using D and T. And if you think about it, this is like y equals mx plus b. You could even discuss that if you want. And then you're going to create your own. So you're going to create your own race, but you're going to choose a different color for each one. So the red would represent your first, the blue would represent the second one, so you do this one for your second one, the purple is the third, and the orange is the fourth. And be sure to use the line tool, and then you will create the own race. This last screen would be an excellent artifact in a portfolio. A student could insert a picture of their graph and then talk about what happened in the video. They could screen capture it with their, they could play the race and screen capture this whole thing with their own video and use that as part of their portfolio as well. So this would make an excellent activity. And then finally, there's a couple of questions at the end. This is a good way to check their understanding, if they truly understand proportional, non-proportional, linear relationships, and systems, because that's what we're looking at in this activity. We're looking at more than one line or more than one function at the same time. So that concludes the Desmos activity. As you can see, there are 9 screens in this activity, so I would say most of your class period will probably be spent on this activity. I do have this scheduled for 1 to 2 days, but this should be probably the longest part of this lesson. Let's go ahead and look at the next part of the lesson. Now this next part is a revisiting of the stacking cups problem. I've just grabbed a picture out of a video that I'm about to show you and put it here just to spark some conversation, and then in the next slide, same picture, but it's saying watch the video, what is the question? So what I will do in your teacher notes, on your slides, and also in your guide, you will get a link to this page, which is an activity that's posted on the web about stacking cups. So this video is 28 seconds. I'm going to go ahead and play it so you can get an idea of what it's going to sound like. And so you can see there that the heights match. There's answers. I'm not going to scroll down too far, but anyway, there's Act 1, Act 2, and Act 3 are all posted here. So you'll get a link to this. Now, how will you handle this with your kids? Well, for this activity, I do tell the students to ask your teacher what to do for Act 2. So you're going to show them the video, and then you can decide how you would like for the kids to work through the task. My recommendation is to have them go to the boards and ask for multiple representations of what's happening. So first could be a table of some data, maybe an equation, maybe a graph, but at least 2 representations is what I would ask the kids to give me. So that is the heart of it. At this point, any formal teaching them how to do equations, solving systems algebraically, that is not what this is about. This is about them getting an understanding of what it means to have a system, and that is 2 distinct functions that happen to intersect somewhere. And so that's kind of what we're at today. This whole lesson is just building a good intuitive understanding of what systems are and how they behave. But it is not a lesson where you're expected to teach them how to solve by substitution, or although they may figure some of that out, some of them probably will, and that would be awesome. But the main idea is to get them to look at systems holistically and intuitively, and that's the goal. Now, once they finish their 3-act task, they should take a picture of their work they did with their team, whether they did it on the whiteboards in the classroom, or if they did it at their seats, maybe they did it on a piece of poster paper, or they just physically stacked the cups and recorded it on notebook paper. That's fine. Whatever they use, they need to take pictures of their work and maybe type some text on this slide to kind of summarize what they discovered about the stacks. Okay, the next activity is solving systems using graspable math. And so for this activity, the first 4 slides are basically looking at different representations of functions. So you'll notice there are no equations for these first 4. So the first representation is a table, and then with that one I gave a graph. And they're basically going to grab these markers and pull them over here to mark the value of x. It's not 2, by the way. Mark the value of x where the output, or the input where the outputs match. So they'll need to mark 1 on this axis and 1 in this column. And it's the same value, the x value that has the same output. So the directions say which input produces the same output in the table and the graph. Mark 1 input in the table and the same input in the graph. They have to basically drag both. So once they mark, let's say it was 2, they would mark the 2's. Now this isn't correct, and when it's wrong it'll turn red, and it'll leave behind a little dot so that they'll see what they tried before, and then they'll try again. As soon as they get it correct, they will be able to go on to the next item. So the next hot spot is the same deals, different graph and equation. Now here we have a function machine, so the outputs are not listed. They would need to figure out what they are. Now they could go to PolyPad and actually create this and do it. I think that's probably a little overkill. Or they could just use this tool to click on the box here and put the 2 in there and then work it out if they need to do that. Like if they can't do it in their head, I think most kids probably could do this one in their head. So if you put in a 2, you get out a 1. Well, if you put in a 2 here, you get out a 4. So that one doesn't work. So they would reset and do it again with the 3, 5, and 6. And they're looking for an input that produces the same output that they see in this table. and then they're going to drag these markers to the input, the same input in the table, and they'll pick one of these. So they're going to do the same thing with this function machine. You'll notice the function rule is at the bottom of the machine, and this is not a linear function, but that's okay. At this point, students should know how to square a number and add a 1 to it. So we did have a nonlinear function for our machine, but they do have a little pad over here. This part is not considered part that's graded. I wish they would take that language out, to be honest, because I don't really discuss grading when we're doing these, but yeah, tell them they are expected to use it if they need it. So that's what it's there for. Now these last three are basically exercises, and they are trying to figure out what one apple and what one banana is. Now this first one is pretty self-explanatory because it's giving you the cost of one banana is exactly the same as 3 apples. I'm not going to tell you how to do that, but that one should be pretty easy for most of the kids. This one is telling you one banana is the same as one apple plus $1, which is not that reasonable because we all know that bananas are super cheap, but let's just go with it. And then the last one, this one's the hardest one, I think. And it said that 3 bananas was the same as 5 apples. How are we going to figure this out? Now, a lot of kids are going to guess and check at this point. In fact, most kids are probably going to guess and check at this point. They're not going to use any formal methods where they're writing systems and solving systems. And to be honest, I don't really want them doing that right now. I want them to have a good grasp of what's going on, and they don't usually get that by solving equations. In fact, most kids forget what's going on when they're solving equations. So the goal is to keep them engaged. They may get stuck on these last 2. I think most of them are going to get 5, but a lot are going to get struggle on 6 and 7, and that's okay. If they don't get them, I wouldn't be too concerned at this point. We are going to learn some formal methods that make these a lot simpler. But yeah, I would just see what they know. This is a good chance for them to think, to work with their partners or their teams to help them. And let's just see where they are. This is the whole point of this entire assignment, really, is to see what they already know about systems, what strategies they've already learned that they can employ, and see if they can make sense of it. Okay, the last activity is a quick little, well, I say quick, but we'll see, GeoGebra task. It is a puzzle, and they do need to work with a partner. So in this case, I usually had teams of 3 and 4, so I may have to move kids around and seat them with people. You can come up with strategies to partner your kids. Some people use playing cards. Some people use popsicle sticks, or they give them a number when they walk in the door. I mean, there's tons of ways to partner up your kids. But I usually would just have teams split into 2 groups because I had 4 kids in a team, unless somebody's absent. And then, of course, you got to figure that out. But however you want to do it, try to get these kids working together with another person. But they're going to click here and go to GeoGebra. And the goal is to complete this task. So you have a number associated with each of these shapes. And so if you notice across the top here, they have 21. That's telling you the sum of these 3 numbers is 21. The sum of these is 17. The sum of these is 21. They're going to take a picture when the score total is 10. So they need to get at least, they'll have to get 2 of them right, I think, to get a score of 10. They may have to do more than 2 if they miss one. But you want a total score of 10 or more, and work it with your partner. Take a screenshot with the total score of at least 10 showing, and then explain the process that you used for the shapes. How did you figure these out? What were your strategies? Some of these are simple and they will do very quickly. There was one, it took me a minute to figure out, and that was even using some algebra. I was kind of cheating a little bit and not using that intuitive approach that I was trying to get them to use. But it depends on the puzzle, but they're very good little puzzles, and it is a good opportunity to look at systems of equations without actually writing any equations. And this concludes our system activities. Our next assignment will look more at formal methods, specifically graphing and maybe a little bit with equations. But we'll be looking at systems again using an algebraic and a graphical approach. Y'all have a great day.